The Kuma community call. Today we decided to spend some time discussing the MADR on how to make transition to the new policies. This MADR is currently in progress, but I think it still makes sense to look through. If you have any questions, please ask them now so we can use this time to actually make everyone familiar with the MADR. So the context and problem statement is today new policy in GA, and they are the recommended way to configure Kuma. At the same time, old policies are not deprecated yet. They are still in use by majority of Kuma users from what we can see. Yeah, and the goal is to provide a way to transition from old to new policies. And yeah, having this way, we will be able to finally deprecate old policies in the future. I'm not saying it's going to happen in 2.7, maybe later down the road, but yeah, we still should have a way to migrate and then deprecate policies, old policies. And what do we want from the transition process? I put here three things. First, predictability. So you want to know how the policy will affect the data planes without the actual applying the policy. So kind of you should have a sneak peek of what's going to happen. Next thing is a short feedback loop. We don't want to have one switch so that now all old policies stop working and all new policy start working. So we don't want that. Ideally, we want deliver new policies with a small portions and being able to quickly verify if they make sense, if they work, and quick rollback if on the previous step we figured that new policies are written with some mistakes, or if that's not what we want, we should be able to quickly roll back the change. Yeah, and one of the instrument to do predictability is shadow mode for policies. So we can have a label. For example, this is just an example. It can be any label that has shadow. And in this case, policy is not applied for real, but we have some endpoint that will show JSON patch for Envoy configuration as if this policy is applied for real, but it's not applied, right? So that's how we could achieve predictability, and we will look into the examples later, how it works with a proof of concept. So how do we want to achieve short feedback loop? Well, first thing to achieve short feedback loop is already implemented, and it's by design that all the new policy can coexist, but a new mesh timeout takes over old timeouts when it's applied. That's why you can for example, transition to new mesh timeouts, but still you can have old traffic permissions, for example, or old socket breaker. So you can independently transfer each policy type. Another thing for short feedback loop and small portions is a top level target ref mesh subset. When you created a new policy, you can apply this policy only to a number of deployments, not to the whole mesh. So for example, you will mark your deployment with opt-in for new Kuma policies equal true, And then new policy you said uh, apply to the tags opt-in for new Kuma policies. And that way, the new policy will be applied only to one service, for example. And yeah, this is a good way to apply policy only for a new application, only, sorry, not for new, only for one deployment, and being able to observe this deployment, its metrics, its traces, that it's all good, and then roll out the policy to all deployments. Quick rollback. I think it's kind of implied that basically if you just delete the new policy and you still have old policy, then old policy will uh, work because because we are able to test new policy without removing old policy. This means we can quickly do rollback and everything should work. Yeah. Then I created some examples. Timeout is pretty difficult policy to migrate because we change many places. Like we change, for example, previously we provided idle timeout on the listener, and now we set the idle timeout on the cluster. It doesn't change the way it works. It's just different place in the configuration. That's why if you had 3 timeout policies and you're replacing them with, you actually need 4 now because I'll explain later why. So you replace them with mesh timeout policies, you will get, even though it will work absolutely the same, you still will have 12 changes in your JSON patch. So you have to look through all these 12 changes and understand that all of them make sense. And that's what I did here. I walked through all 12 changes and request header timeout and max connection duration. These first 2 and this. So 5 out of these timeouts are just basically previously were omitted, unset, and now we set them to 0. That's why we see them in the JSON patch. Same story, not same, but similar story with idle timeout. It was set on the cluster. Oh, sorry, it was set on the listener, and now it's set on the cluster and disabled on the listener. So yeah. Yeah, question?
Yeah, can I ask questions now or should I wait?
Yeah, ask now. I forgot to mention that. Yes, sure.
Okay, so do we like, I guess we plan to do this for all policies, right? So like a quick summary of things you can expect are changing, right? So the person doesn't need to actually figure out that this timeout moved from a cluster to a listener or whatever, right? I guess we could provide a list of such things so there's less to actually manually check.
You mean if we can do this automatically? Or
Well,
yeah, I mean,
automatically would be great. I guess we just could have a doc just for
yeah.
every policy, right?
So when you look at the policy, I can imagine you have a doc, something like that, that says if you see request header timeout and max connection timeout, like don't be afraid, this is expected because we just moved or we just added this timeout. It wasn't possible to modify them previously. Yeah, we can have some kind of guidelines on how you should review this list. And yeah, Mesh circuit breaker, for example, is great because it actually shows you empty JSON patch list. I guess because the new version is almost exactly the same from the implementation point of view as old version. That's why it's empty. And yeah, that was a nice surprise. For fault injections, I haven't even attempted to do this because I don't think you want to migrate fault injections like smoothly. Just remove old one, create new one, and that's it. It doesn't look great for traffic permissions, to be honest, because we rename the policy in Envoy. We used to take the name of the policy, and now we always set mesh traffic permission, like the quote mesh traffic permission is always like that. And that's why uh, JSON diff looks like this. Even though the policy is exactly the same, you still will see remove this. Yeah, question.
Yeah. So do we actually need this change? Can we just go back to the original naming so we actually see the real div, not like something that shouldn't be there?
First of all, you might name your policy differently, right? And you will still see this. Second thing is that I think it's nice we don't have policy name uh, because uh, it's not really one-to-one now, because now you can have many policies contributing to the list of principles. So then there is a question of how you pick up correct policy. And that's why we decided we'll just go with the mesh traffic permission.
I
Okay.
think there's an additional problem here that mesh traffic permission can be applied on L7, right? Like as an HTTP filter, whereas with traffic permission, we just did L4. So even if we were to preserve names, right, you would still have like a similar situation.
Yeah, I haven't actually checked this.
Yeah, I see here we see L4, right? It's a filter on the TCP service,
Yeah,
right?
because you will have HTTP connection
Yep,
manager somewhere in
yep,
the
yep.
path. Yeah, right. Still, but I guess you can review this, that these services will be allowed. It's not ideal, but okay. Yeah. The last thing I want to mention here is that for proxy templates, it's probably don't need this for migration, but it's just nice to have such shadow mode because it can allow you to debug your uh, proxy templates pretty easily. You can see how it's going to change config dump. Yeah, and there are 5 policies left for me to cover with some examples. And also what's missing in this MADR is that the order that makes sense for transitioning. Because I think Lukasz mentioned this previously, what policy you should take, what policy you should upgrade first, what policy you should upgrade uh, second. And I don't have this right now. But yeah. Do you have any questions?
Yeah, I have a question about shadow mode.
Yep.
Can we go back to there? So, um, how does it like is the like are the snapshots like one is with the old policies, right? And shadow is with the old policies plus the shadow policies, right?
Yes.
Okay. Um, do we know if this is going to be a big performance hit? Like,
Mm.
is it?
Yeah, I can answer this.
Yeah, can we just maybe, I don't know, enable the shadow mode on like one CP that is excluded from, serving uh actually serving DPPs?
Yeah, I think the ideal implementation will be even if you have policies with shadow applied, it costs 0, and it only starts costing something when you call the endpoint. So I think this would be the best so that we can calculate the snapshot on demand. Yeah, with POC, how I did this today, it's costly because basically I calculate two snapshots and I put both of them into snapshot cache, and then I can compare. But uh, with the good implementation, it should be only on demand.
Okay, makes sense.
Yeah, I invite you all to comment on this MADR. I will, like I said, update. I add more examples, and I already got comments from Charlie and Lukas. I'll fix them as well. So, are there any other questions? Yeah, if this is it, then maybe you have questions not for MADR, but in general, Kuma questions. If not, then yeah, have a good day. See you later.
Thanks. Bye.
Bye.